In this video, we're going to do a design overview of gathering GPS data by using ViewModel and LiveData in Android Q and Kotlin. There are a lot of moving parts here, so in this video we're going to take an overview look at what we're going to need to do to implement these. Next, we'll do a separate video where we actually write the code to do the implementation. So this video is an overview appropriate for many audiences. The next video in the playlist will actually do the implementation. Here are the steps, and as you can see there are several, and it can get a bit intimidating. Let's look at it a different way. Down at the bottom we have some items that are observing on live data. In other words, when they're turned and looking at the live data, they can see it, and when they're turned away, they don't see it. This would be an activity or a fragment within an application, essentially something that we want to show the GPS data. Now, up above, we have an Android view model, which is a bit different from the view models that we've seen before. The view models that we've seen before are what we would traditionally call a POCO or a POJO, plain old Kotlin object or a plain old Java object, and don't have any hard dependency on the Android operating system. But for live data, we actually need to know a little bit about the application, so we need a special kind of view model called an Android view model. So what happens is the Android view model will instantiate a class that we're going to design called location live data, and then it will make that available essentially as a member attribute, something that can be seen by other things like our activities that are going to be observing on the GPS. Now, we have GPS, which we can gather from the device itself, but here's the trick. If we don't specify how frequently we receive GPS, we might find that we receive GPS way more frequently than we expect, and that can run the battery down. The first time I ever wrote a GPS Android application was back in, I remember very well, the winter of 2012. And I put a toast up every time I received a change of location because I was curious how frequently it would fire if I let it go. So I opened up my app, and I toggled location updates, and I was getting toast very, very frequently. I closed my app, and guess what? The toast kept coming. So that's a little trick about receiving location updates is number one, we need to throttle them so we don't run down the battery. Number two, we need to turn them off when we exit our application so we don't continue to ask for updates. Now, some good news, we know that live data follows this observable pattern, and so essentially we're either looking at it or we're not looking at it, and it takes away a lot of the challenges we had before where we had to remember to unsubscribe from GPS. So I also talked about throttling these updates, and how do we throttle? Well, what we're going to do is the location live data is going to create a companion object called location request. And on location request, it specifies an interval, a fastest interval, and priority. Interval means how frequently are we going to request GPS updates and take the battery hit for that. Fastest interval is kind of neat. It allows us to piggyback on other apps that have already requested location data, and then we receive the location data as part of that request, and we do not take a hit for the battery usage because it's another app that instantiated this request. Well, the trick is that other app might have a different interval than we have. So our interval might be, say, 5 minutes. The other app might be 5 seconds, and maybe when the location changes, it might cause some behavior to happen. So fastest interval is saying how quickly do we want to receive free updates that we get from other apps on our device. So if another app is requesting 5 seconds, maybe we say, you know what, every 15 seconds is fine, ignore the others. Priority is also a neat thing that we can specify because we can say the trade-off between using the battery and location accuracy that we want for our application. If we're doing turn-by-turn directions, we probably want high accuracy, but that's going to come at a cost of using up the battery. On the other hand, if we just want to show the weather, maybe we just need city data, and it doesn't need to be tremendously accurate, so just a rough idea of where we are will be fine. Now we have our limits in place, and we see that it can treat our GPS updates a couple of different ways. It can say, oh, you know what, I just received a request and we're not beyond the fastest interval yet, so I'm going to bury this one. But this one, okay, yeah, I'm within the interval or the fastest interval and the priority is accurate, so I'm going to go ahead and send that one off to my location live data. Now in location live data, we're going to make a little DTO that represents the location information that we want to be observed. It'll have things like latitude and longitude. So when location live data receives this, it's going to receive this using a listener callback, if you will. So we'll need to make a little callback. And that callback is going to take the location GPS data and turn it into an object of this DTO. And then the object of that DTO will be exposed and observed by anything that is observing the live data. And we know because this is an observable in live data, as soon as an application looks away, if it does something like an on pause or an on stop or on destroy, it simply is not going to receive these updates anymore, or it's not going to look at the updates, it's not going to see the updates. Now, a few other things that we need to consider. Outlook on location tracking and privacy has really changed over the last few years, and a lot of users are hesitant to grant that permission. So we're going to need to update the Android manifest and add some permissions. We're also going to need to prompt for just-in-time permissions for find location or course location, depending on the data that we want to receive. In addition to that, we will need to add a library to our build.gradle to include this Google service, essentially, that will give us location data. So that's an animated look at this list. I hope that that animation maybe explains this list in a bit more detail. I believe we covered just about everything. A few more things that we'll see in the details, so stay tuned for the next video when we'll jump right in. Thank you.